So for the second part of the alum video, I will be talking about the current growth of our crystals, the amount of aluminum we started with, and the final mass of alum that we generated from it, which is right here, this alum right here, this powder. And then I'm also talking about the experimental yield, and then also what variables and factors made this yield less than 100%. So to start off, these are our dissolved alum. This is our dissolved alum, and as you can see, there's some small formation of crystals there. Here, let me try to get it better a little bit. Yeah. So there's a small formation of crystals at the bottom. This is due to actually an accident which occurred where in the first week I actually spilled, or this was spilled, not by me, but by my roommate, but this was spilled, and the small crystal particulates are actually on the Chem wipe, surprisingly enough, which is why the solution has less crystals than you would expect and also less liquid. And as you can see, it's kind of shiny from those crystals. So they've grown pretty well. We'll see next week exactly how big they'll get. And then in terms of the aluminum and the calculations that we went through, so at the beginning, we actually had 1.01 grams of aluminum, a pure aluminum from aluminum foil. And then we dissolved that, and when we filtered out any solid particulates, there's 0.08 grams of solid particulates left. So that means only 0.93 grams of aluminum was actually dissolved into the solution by the acid. And then from that, at the end of the experiment, there was 14.16 grams of alum with the filter paper. So then when we subtract out the 0.23 gram filter paper, we get 13.93 grams of alum produced from this lab. So from the first alum of the solid, we go through the process, and the whole process results in this alum, as we talked in the last video about. And the molar ratio is, if you put in 1 mole of aluminum solid, you'll get out 1 mole of alum. So then from that, we can calculate how much is expected from the 0.93 grams of aluminum in the beginning. So taking into account the molar mass of aluminum, we can figure out how many moles, which is right here, 0.93 grams over 26.98 grams per mole. That'll give us a number of moles, which is 0.345 grams per mole. And we also use the molar mass of alum, which is you sum all of its components, so the hydroxide, the hydroxyl groups, and then also the potassium, the aluminum, and then the sulfate. And that gives us 474.11 grams per mole. And then we know it's a 1-to-1 ratio. If we put in 1 mole of this, we get 1 mole out. So that's why we take the number of moles of aluminum, we multiply it by the molar mass of alum, and we get a theoretical yield. So what we should get if everything goes to plan, 16.36 grams of alum. And our experimental yield, which is how much we actually measured up here, is 13.93 grams. And by knowing that, so to calculate percent yield, we take the 13.93 grams divided by the 16.36 theoretical. So experimental over theoretical, and then we multiply by 100%, and that gives us 85.1% yield, which is pretty good. So the yield was actually surprisingly high, in my opinion, and it varies depending on the reaction. And for this reaction, like something and all the constraints of the reaction. So, temperature, time, the humidity, there's a lot of different constraints. So we worked with this, and we filtered it, and we had to let it sit on a hot plate. We had to let it redissolve. So if at any stage the reaction doesn't occur fully, then you'll never be able to get your theoretical yield. So every reaction every step, each of the 4 steps in the previous video, has to be fully completed. So here to here has to be 100% yield, then 100%, then 100%, then finally 100% again, for this to be a final experimental yield that's equal to the theoretical. So in my opinion, the yield is pretty high. Previously, I've gotten much lower yields, of course. And some other factors and reasoning is that, like, in terms of letting it dissolve into the acid, and then also getting it out of the acid in the ice bath, like over time the temperature of the ice bath warms up, so it's really hard to control and make it so that it actually pushes the reaction fully to the right, so that you can get the full amount of alum out of the solution. But yeah, overall the growth looks pretty good for this week, and that'll be my video.